The distance formula is derived from the Pythagorean theorem. The distance formula is given by the formula d, which stands for distance, equals the square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. Essentially, what you're doing is finding the distance between the x values, so the horizontal distance, and then you're also finding the vertical distance. Find AB when A -4, 1 and B is 3, -1. So one thing you could do is graph the 2 points on a coordinate plane, connect them, and then create a right triangle and use the Pythagorean theorem. But the distance formula gives us a quicker way to find the distance. So it doesn't matter which point you let be x1, y1, and x2, y2, as long as you maintain consistency. So to find the length of AB, we're going to do the square root, and we're going to take our x values, -4, and we're going to subtract our other x value, 3, and square it. And then we're going to take the first x value, 1, and subtract the first y value, 1, and subtract the second y value, -1. So -4 minus 3 is -7. And 1 minus -1 actually becomes plus, so that is 2 squared. -7 squared is 49. Remember that when you square a number, it's always positive, so don't ever write a negative number after this step. 2 squared is 4, and this 49 plus 4 is 53. So the square root of 53 is the exact answer. But you can round it and make it an approximate answer by using your calculator. I know it's going to be a little bit more than 7, and let's see, it is approximately 7.3. So either of those would be acceptable answers, the square root of 53, which is exact, and then approximately 7.3. Now, some of you might be able to look at the 2 points, so like -4 to 3, and come up with the distance between those numbers just by looking at them. So from -4 to 3 is 7, or maybe you look at from 1 to -1, and that is 2. So you can also kind of skip the step of subtracting them and do the subtraction more in your head. I tried to show you every step in this problem since it's the first time that you've ever seen one of these. On example 2, we're finding the distance between the 2 points on the graph. So on this one, it's the same type of problem that we just did, but it's going to be really important that you identify those coordinates correctly, because if you write the coordinates incorrectly, then you're likely to get the wrong answer. So let's look at the graph and look at that top left point. It is left 5 and up 3, so that would be -5, 3. I'll write that so we can see it a little bit better. And then the second point, left 2, down 3, so that'd be -2, -3. Okay, so if we're going to use the distance formula, we're going to subtract our x values, -5 minus -2, squared plus, and then the same thing for y values, 3 minus -3 squared. -5 minus -2 becomes a positive or +2, so that is -3 squared, plus 3 minus -3 becomes 3 plus 3, which is 6 squared. -3 squared is 9. 6 squared is 36. Doing the math in my head. And then 9 plus 36 is square root of 45. So if we go to find what that is as a decimal, if you're using the 36X Pro, square root of 45 simplified is not 3 root 5. And 3 root 5 approximated is about 6.7. So in the first example that we did, I said that one thing you could do is draw a right triangle. So I want to show you how that looks like on this graph. This would definitely be an option if you had a graph. And essentially you just make a right triangle. And then you count the sides of the right triangle. So that horizontal side is 3. That's why we got 3 right there when we subtracted the x's, because the horizontal distance is 3. And then that vertical distance, 1, 2, 3, 4, 5, 6, that's why we got 6 when we subtracted the y values. And then if you were to do the Pythagorean theorem, 3 squared plus 6 squared equals x squared, or whatever you want to call it, you would still get that square root of 45, or approximately 6.7. So just another way to look at it visually. This is a play on something that we've already done. Don't think of it as a whole brand new concept. All right, for example 4, we are given 2 points again, so we can just stick with our formula. This would not be a good one to try to use the Pythagorean theorem with because you don't have a picture. So our distance is equal to, we're going to subtract our x values, and our x values are -7 and 11. So -7 minus 11 squared plus, and then we're going to subtract our y values, -2 and 3. So -2 minus 3 squared. -7 minus 11 is -18. And then -2 minus 3 is -5, and then don't forget your square. Again, at this point, please be careful, especially if you're using a calculator. If you don't know what -18 squared is and you're using a calculator, make sure you type in -18 in parentheses, because if you don't put the parentheses, it is going to tell you that your answer is negative because it does order of operations. But -18 squared is positive 324. Remember, it will always be positive at this step. -5 squared is 25. If we add those together, we're going to get the square root of 349. The square root of 349 is approximately 18.7. So your exact square root of 349, your approximate is about 18.7. Remember that if you can tell the distance without subtracting them, that's fine. So if you look at those x values, -7 and 11, and you think in your head, okay, well, those are 18 units apart, you can go straight to the 18 squared. And then if you look at your y coordinates and see -2 and +3, and you know those are 5 units apart, then you can put 5 squared. But that's only if you can do that mental math. If you can't, stick with the formula. All right, our last example is another graph. So let's correctly identify the coordinates. So the point on the left, we're going to go left 5 and down 4, so that would be -5, 4. And then the point on the right side is 4, 0. Be careful not to put 0, 4. That's a very common mistake. So from here, you can do a couple different things. You can do the distance formula, or if you prefer to draw a right triangle and use the Pythagorean theorem, you can definitely do that. That is completely up to you. So there would be your right triangle, or you could draw it down like this as well. All right, so I'm just going to stick with the distance formula since that's what the lesson is. So square root, let's look at our x values. They're -5 minus 4 squared, and then our y values 4 minus 0 squared. -5 minus 4 is -9 squared, and 4 minus 0 is 4, and then don't forget the square. All right, -9 squared is 81, 4 squared is 16, and 81 plus 16 is 97. So the exact value is the square root of 97. The approximate value is going to be just under 10, so approximately 9.8. If we were putting units on this, this would just be regular units. Since it's a distance, you could write units at the end of every one, or if they told you it was centimeters or inches, you could do that as well, but it's not necessary. In our last problem, this one's a little bit different. We're actually given the distance and one full coordinate and then half of a coordinate, and we're trying to find the value of y. So it says the distance between 3y and negative 6, 2 is 15 units. Find y. So we're going to set this up with the distance formula, and then we're going to solve for y. So, all right, so we got the square root. We have 3 minus negative 6 squared plus y minus 2 squared equals 15. Then we're just going to solve. So I'm going to simplify the inside a little bit. I'm going to do the 3 minus negative 6, which is 9 squared, and 9 squared is 81. So I'm going to make this look a little bit better by changing that to 81. And then we've got to think about, well, how do I get this y all by itself? There is a lot to get rid of, but we really can't get rid of anything until we get rid of that square root. So the first thing I'm going to do to get rid of the square root is to square both sides. And on the left side, all that's going to do is eliminate that square root. It's not going to change the 81 or the y minus 2 squared. It's just literally going to get rid of the square root. 15 squared would be 225. Okay. We also need to get rid of, on the left side, we need to get rid of the 81, we need to get rid of the minus 2, and we need to get rid of the square. I can't touch the minus 2 until the square is gone, but I can't touch the square until the 81's gone. So the next thing I'm going to do is I'm going to subtract 81 from 225, which is 144. All right, so this really comes down to a problem like what we talked about last year in Algebra 1. So now we're going to get rid of the square by square rooting. And here's where you have to be careful, because most of you are going to say that the square root of 144 is 12. And although you're not necessarily wrong, you're not 100% right either, because it could be positive 12, but it could also be negative 12. So essentially you're looking at two possibilities. It could be y minus 2 equals 12, or y minus 2 equals negative 12. So now if we add the 2 to both sides on both equations, we're actually going to get two possible answers for this particular problem. So 12 plus 2 is 14, and negative 12 plus 2 is negative 10. So my two possibilities for y are 14 and negative 10.